Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. One of these mysteries is centered here, in the Grand Canyon in Arizona. Close to 1 billion tons of rock have been carved out of the ground. The canyon left behind could hold all the river water on Earth and still be less than half full. For more than a century, scientists have debated how and when this vast chasm was created. And now, geologists are uncovering fresh evidence of how the Grand Canyon fits into the ever-evolving story of how the Earth was made. The Grand Canyon, one of America's most spectacular natural wonders. A canyon 18 miles across at its widest point, 277 miles long, and more than a mile deep. It is so vast that it can even be seen from space. Although Hell's Canyon in Idaho is almost half a mile deeper, and Australia's Capertee Valley is nearly a mile wider, the Grand Canyon remains the most famous of them all. And it also holds one of geology's greatest mysteries. Just how did the Colorado River, only 1/10 the size of the Mississippi, form such a large canyon? The answer has eluded scientists for more than a century, because many of the clues they normally rely on have been swept away by the river's water over millions of years, or buried by landslides, or destroyed by volcanoes.
It seems like we should understand perfectly how the Grand Canyon formed. The problem is we've lost a tremendous amount of evidence. It's like a murder mystery where most of the evidence is lost. And so the best we can do is piece together the evidence that we have.
Even so, slowly but surely, this geological icon is giving up its most ancient secrets. The canyon's richly colored layers offer scientists one of the most complete geological records on Earth.
The first concept you have to get your mind around as you're thinking about the Grand Canyon is that the stories told by the rocks are exceedingly old, millions and billions of years.
Karlstrom and his team are setting out on a grueling geology field trip along the Colorado River. It won't be an easy ride, because this 1,450-mile-long river packs a punch. More than 800 million gallons of water can flow down the Colorado every hour. More water every second than the average U.S. household uses in a year. Karlstrom is investigating the ancient history of the land that was here before the Grand Canyon even existed. And for that, he needs to identify its oldest rocks. He is following in the footsteps of pioneer explorer John Wesley Powell. In 1869, he was the first man to successfully ride the Colorado through the entire length of the canyon.
All of us who work in the canyon as scientists admire John Wesley Powell immensely for his pioneer and scientific exploration of the Grand Canyon. And the questions that he framed are still questions that we work on today.
One of Powell's discoveries was these intimidating black rocks at the very base of the canyon.
Well, we're deep in the Grand Canyon, right by the Colorado River. You can see these spectacular black rocks. Actually, John Wesley Powell called them ugly black rocks, because for him, these hard rocks made bad rapids, and that was harder on his trip. But for those of us who are interested in the early history of Grand Canyon, these rocks are the bonanza.
Powell had no way of dating these rocks, now identified as Vishnu schist. All he could conclude from their appearance was that they had once been molten, deep underground. But Karlstrom has an advantage: modern instruments that can accurately date the rocks by measuring radioactive decay. And the first step in figuring out what happened here in the ancient past is to record when these rocks were created.
These rocks are about 1.7 billion years old. It's less than half of the age of the Earth. So we have a great story here in the Grand Canyon of the last almost 2 billion years of Earth history.
But Karlstrom needs more information. And these ugly black rocks hold another crucial clue to what this land looked like before the canyon was cut. They can tell him not only when they were formed, but also precisely how deep in the Earth's crust they were made. These tiny stones, embedded throughout the ancient boulders, are literally jewels. Garnets that only form under immense pressure. The sort of pressure that's found when layers are crushed by the weight of millions of tons of rock on top of them.
The silver bullet clue is the garnet.
These garnets are the key to understanding the amount of rock above us.
By analyzing the chemical structure of the garnet, in particular its calcium content, investigators can determine how much weight of rock was crushing down upon it at the moment it was made.
In simple terms, if you analyze the garnet and you see higher calcium content of the garnet, it means you're deeper into a mountain belt, more rocks above you. So we take these garnets back to the laboratory. We cut a very thin section. We put them under an electron microprobe. And the scientific result after this analysis is that we were 6 miles deep beneath the surface of the peaks, which were above us. And that's a long ways.
So, nearly 2 billion years ago, before the canyon evolved, ancient mountains 6 miles above sea level stood here, towering peaks as high as the modern Himalayas. Over the next 500 million years, these mountains were worn away by the relentless forces of erosion. Over millennia, the freezing and thawing of ice cracked open the rock of the mountain slopes. Wind and water carried the rock debris down towards the oceans, leaving behind a flat and featureless plain with no sign at all of a canyon.
Geologists learn to visualize the way that this place looked in the past. Knowing how to read the texture of the rock, the kind of rock it is, the fossils that are in it, geologists can, it's like a detective story. You can uncover what this place looked like billions of years ago.
This is now desert country, more than 300 miles inland. And yet, these shells, encased in solid rocks, are ocean fossils.
In this one cliff, you can find fossil shells that look like you'd pick up on the seashore today. They die, they fall to the bottom of the seafloor, and they get trapped and die in the mud at the bottom of the ocean at the time that they're being deposited.
Shells like these come from shallow tropical waters, an inland sea that first arrived here 500 million years ago and covered the flat, low-lying plain. But that did not happen just once. Many different layers in the walls of the Grand Canyon tell Karlstrom that over hundreds of millions of years, this land has been submerged by the sea, not just once, but at least 8 times. The last time this part of Arizona was under the sea was around 80 million years ago.
As we go higher in the layers in the Grand Canyon, we have different age seas which are depositing different kinds of rocks, different environments, different fossils that live at the different times. This chap